When we perform a t-test, we have a choice as to whether we use a one-tail versus a two-tail test. So a two-tailed t-test will have an alternative hypothesis that the means are not equal. Alternatively, a one-tail test will specify that it is testing for one direction, so whether one mean is greater than the other. Which form of t-test we use is really dependent on the question that we're trying to answer. With the t-test, we're trying to test whether there's a difference between the two means. This is just different ways of going about it. When the question is basically just, is there a difference between the two means? We're testing whether the difference is equal to zero or whether it's not equal to zero. So for example, let's consider the average income between genders. It's a common question in statistics. If the question is simply, is there a difference between these two? Is there a difference between male and female earnings? The H sub O, the null hypothesis, would be the mean of male income minus the mean of female income equals zero. In other words, they're the same. And the alternative hypothesis would be, in this case, the mean of male income minus the mean of female income does not equal zero. This would be considered two-tail test because it could be either direction. We're testing whether there is a difference, so whether female income is higher or lower. It goes both ways. We're not asking if the male income is greater than the female income or if the female income is greater than the male income. We're just testing whether there's a difference. We don't care, we don't think about ahead of time which way the relationship goes. So looking at the normal distribution, and we have here on the slide, we have rejection regions, so where we reject the null hypothesis on each end, down here and up here. This would be like saying male income is higher than female income. This down here would be female income is higher than male income. So we have the two differences, both included in there. Now, one-tail tests are more specific. Here we can see the one-tail test visually. In this case, the rejection region is on the right side, but it could also appear on the left side instead. So, for example, we may test whether men make more than women. So we would change our alternative hypothesis from the two means being not equal to each other to reflecting that to the average of male wages being higher than the average of female wages. So right about here would be the mean equals zero at that center point of the normal distribution. Out here, the mean for males is greater than the mean for females. This is the direction that we're looking in. So this is where the only rejection region is. We're not concerned with the alternative where female wages would be higher than male wages. Now, if you notice, if you're performing a one-tail test, the significance level will give you a larger rejection region than the two-tailed test for the same value. For the rejection regions up here, because we basically split the area in half. So at a given significance level, it is you are more likely to find you have a larger area for the one-tailed test than you do for a two-tailed test. But that's because you're only focusing on one side of the alternative hypothesis. So for the two-tailed test, it's does not equal, could be either, go either way. For the one-tailed test, you are testing for a specific direction of that difference.